Hello friends, I am Rahul Gawande. Welcome to our channel. Today we are going to start chapter number 3, Polynomials of Maths 1 of Standard 9. Dear friends, polynomials means what? What is the definition of polynomial? If any algebraic expression is given to you, and in that expression some terms will be there, and if all the indices all the powers are whole numbers, then that expression is called polynomial. In short, all the powers should be whole numbers. Now there are some types of polynomials. Types of polynomials based on number of terms, means 1 term, 2 terms, 3 terms, 4 terms, 5 terms, based on number of terms, which are types of polynomials. There are 3 types. First, monomial. Monomial. If there is only one term in the polynomial, then that is called monomial. Only one term. For example, x, one term only, or we can say 2y, only one term, 2y. 2 and y are not separated, that is single only, 2y. Or we can write here z square, single term only. Based on number of terms, these are monomials. First type. Second type is binomial. If there are 2 terms in the expression, then that polynomial is binomial. 2 terms. For example, x plus 2. See, there are 2 terms. 2y plus 5, 2 terms, and that's why that is the second type, binomial. Third is trinomial. If there are 3 terms, then that is tri. Tri means 3. For example, x square plus 2x plus 3. Here, x square plus 2x plus 3, 1, 2, 3, 3 terms, then that is trinomial. These are types based on number of terms. Now next point is degree of a polynomial. Degree of a polynomial in one variable. In case of a polynomial in one variable, because one more type there is polynomial in more than one variable. If there are variable but more than one, then in that type. First let's say degree of a polynomial in one variable. What is the degree? If there are 2, 3, 4, 5 terms, then how to identify the degree of that? But that is in one variable. For example, 2x raised to 5 plus 3x plus 7. As I told you that based on the number of terms, how many terms are here? 1, 2, 3. This is trinomial based on terms. But what is the degree? Now here is 7. What is index or what is power? What is power of 7? 0. Power of 7 is 0. What is power or index of this? Here is 1. Index of this is 1. What is index or power of this x? 5. Then 0, 1, 5. What is the highest index or highest power? Highest power is 5. That's why degree of this is 5. Highest power. Therefore, definition is that in case of degree of polynomial in one variable, highest power is called degree of that polynomial. One more example. 3y raised to 7 plus 5y6 plus 3y raised to 2 plus 6y. Polynomial only. Why is it polynomial? I told, if all the powers are whole numbers, 7, 6, 2, 1, here is 1, all are whole numbers, that's why this is polynomial. What is degree now? What is degree? Then see the highest index. 1, 2, 6, 7. 7 is the highest index, that's why degree of this is 7. Highest power is called degree of the polynomial in one variable. Why is it one variable? Because same variable, y. Same variable means one variable. Highest power is called degree. Now next point is degree of a polynomial in more than one variable. If in that polynomial variables are more than one, then what is the degree? For example, 7m raised to 5 n square plus 5 mn plus 3 m cube n. How many terms? 1, 2, 3. This is trinomial based on the term. Okay, but we want a degree of that, and but variables are 2, mn, mn means more than one variable. Sometimes 3 variables will be there. Then what is the degree of that? Now here we cannot find out highest power because that is mixed. Now at that time you have to add, or you have to do the sum of powers of single term. Now this is single term, no? This is this one and this one. You do the sum, or you add powers of them, whole term. Now here whole term is this. Now you add the powers of their variables. Here is 3, here is 1. 3 plus 1, here is 4. Sum of powers, 3 plus 1, 4. Here you do, here 1, here 1. 1 plus 1, 2. Here 5 plus 2, 7. And now you see the highest in that. Highest sum of powers. Highest sum of the powers. 4, 2, 7. What is highest? 7. Now, types of polynomials, but based on degree. Types of polynomials based on terms we studied. Monomial, binomial, trinomial. Now based on degree, types of polynomials. First type is linear polynomial. Linear means 1. If the degree is 1, degree means now highest index. If degree is 1, that is linear. For example, 7x. Now what is the index? Here highest index means degree is 1, that's why this is linear type. Second is quadratic polynomial. If the degree is 2 or highest index is 2, that is called quadratic. For example, 2y square plus 7. Based on terms, there are 2 terms, right? Binomial, that is. But based on degree, what is highest index means degree 2. Degree is 2, that's why this is quadratic, second type. Third is cubic. If the degree of that polynomial is 3, means highest index is 3, that is cubic. For example, 3x cube plus 2x plus 5. Here index is 0, here is 1, here is 3. What is highest index? 3, means degree is 3. And degree is 3, that's why this is cubic. These are the types: linear, quadratic, cubic, based on degree. Next point in this introduction is that standard form. If any polynomial is given, you have to arrange their powers in descending order, then that is the standard form. For example, I write one example: 2x cube plus 5x square plus 7x raised to 6 plus 2x raised to 5 plus x plus 7. This is one example. Now if you see the powers, if you observe the powers, 3, 2, 6, 5, here 1, here 0, powers are not arranged. If you want to write, suppose this is p of x, this is the polynomial p of x, and you want to write in standard form, then standard form how to write? For standard form, what we have to do? We have to arrange their powers in descending order. Descending order means from bigger to smaller. Now what is the highest? What is highest power? 6. Then that will come first. 7x raised to 6. Highest first. After 6, what is power next? 2x raised to 5. After 5, 3 plus 2x cube. After 3, 2 power plus 5x square. After x, 1 means only x, and last constant. We have arranged their powers in descending order. 6, 5, 3, 2, 1, 0, and this is the standard form. In short, standard form means descending order, arrangement in descending order of the powers. In standard form, we arrange powers in descending order. For coefficient form, we have to arrange coefficients. But for that, it is again important or compulsory to convert given polynomial in standard form. Means if any polynomial is given to you, after that you have to convert in this standard form, and after standard form then coefficient form. Without standard form, if polynomial is not in standard form, you cannot write that in coefficient form. It is compulsory to convert given polynomial in standard form. See example. One example I write here. P of x is 2x raised to 5 plus 3x plus 7 plus 4x square plus 3x cube. If you observe their powers, if you observe their indices, they are not arranged. 5, 1, 0, 2, 3. Powers are not arranged. Means that is not in standard form. We have to write that in coefficient form, but before that we have to convert this into standard form. Compulsory. Now here standard form. For standard form, what we do? We arrange their powers in descending order. Means powers from highest to lowest. What is highest? 2x raised to 5. After 5, 3 plus 3x cube. After 3, 2 plus 4x square. After 2, 1 plus 3x, and at last constant plus 7. We have arranged their powers 5, 3, 2, 1, 0. This is standard form. After converting given polynomial in standard form, now we can write in coefficient form. And now for coefficient form, what to do? Just write coefficients, only coefficients together. Only coefficients. What is coefficient here? 2. Give comma. Separate each coefficient by comma. Second coefficient 3. Third coefficient 4. Next coefficient 3. And last 7. And write all these coefficients in bracket. This is called coefficient form. This is the method to write coefficient form. Now next point is index form. Index form, for index form, coefficient form will be given to us. And we have to convert coefficient form into index form in the form of variable. Now how to? Let's see. For example, now coefficient form will be given, any coefficient form. I write here in bracket coefficient. 7, 5, 3, 2, 8. These are coefficients, and question is that write this coefficient form in the standard form in the form of variable x. Means we have to use variable x for that, and already these are arranged. When any coefficient is given to us, already coefficients are arranged. We cannot change their sequence. Okay, that is in standard form, not in coefficient form. In coefficient form, already coefficients are arranged. Therefore, don't do any change in the coefficient. Now, how to write that? We have to write this coefficient form into index form now. Okay, index form is equal to, now index form, which variable we have to use? X. If it is given in example, then that only, generally x variable. Okay, we have to start counting from right side, powers. Now here you see, here power 0, here power 1, here power 2, here power 0, 1, 2, 3, 4. Means power 4. We have to start from power 4, x raised to 4, and this is the coefficient. Coefficient take as it is 7. First coefficient is 7. Which variable we are using? X. And what is the power? Start from right side, rightmost. 0, 1, 2, 3, 4. That's why here power 4. And now continue. Plus coefficient 5. X raised to, after 4, 3. X raised to 3. Plus next 3 plus 3. X raised to 2. After that plus 2. X after this 1. And plus 8. Constant polynomial, constant number. Last will be always constant number. Now this is index form. 7x raised to 4 plus 5x cube plus 3x square plus 2x plus 8. That is index form of this coefficient form.